All right, I think I got everything set up. All right, so tonight, let's see, I'm gonna work on some natting, just to try and get back into the groove of things after being on vacation. And nat is a subject that I am not good at. All right, so we need to configure R5 to translate packets coming from router 8's VLAN 8 going to VLAN 146. And we can't use any route maps. All right, so let's first verify that we have a route to VLAN 8. And we do. Let's see if we can get to VLAN 146. We can. And we can see that it's going to go via the VLAN 45, so that makes sense for what we are looking for. All right, for NAT, I know we need to, let's see, it goes out gave 158, so IP NAT inside 1.45, IP NAT outside. Okay. So for our NAT order of operations, we need to set inside and outside interfaces. We need to source traffic with an ACL, identify nation of traffic with an ACL. We're going to ignore my terrible spelling and typing skills. All right, and it says use a dynamic pool from the point-to-point sub-interface on VLAN 45. So I think we can just say interface gig 1.45. Now overload would just mean for one, we would need to use overload, I believe. So let's do that, and now we need to IP access list standard 1. We're going to permit VLAN 8 and use the wildcard for that. All right. No translation yet because there's no traffic. check the config. And that access list. And let's see if I did it right. And I kind of close. All right. So what I got wrong is that we don't want to NAT it to the interface. We wanted to do it to a pool. So let's get rid of that. And let's do an IPNAT pool. We'll call it VLAN 45. So let's see. Let's hop over to router 4 real quick. Show IP. Route 155.1.45.0. So I know just from this topology that it's 44 on this side, or .4 on this side, and on the other side it should be .5. So let's make this .16 to 55, 1.45.254. We'll do a prefix length of 24. So, all right, so it can use anything, the NAT pool will allow for anything between 16 to 254. The reason I picked 16 is because of the number of route devices in this topology. We have 10 routers, 4 switches. Maybe there's something using .15. Don't think so. Not 45.15. Yeah, nothing. So we should be able to use it. Okay. The other thing I did wrong is the access list. So let's get rid of this. We need an extended access list. So let's do IP access list. We'll call it VLAN 8 NAT, and we're going to permit all IP from 155.1.8.0 and going to anything. Probably could have said, actually it says anything going to transiting. You know, I don't like their solution because it's not specific enough. So we'll say anything going to 155.1.146.0. All right, now let's do IPNAT inside source and list. VLAN 8 NAT. Pool, probably could have called it VLAN 45 pool, but too late. And we don't need overload because basically everything can get its own IP from that. Let's check that. All right, so we got our NAT pool. And we got the length. So let's add that to the note. All right, so if we built a NAT, because we don't need to add and change any routing or do anything because we're using an existing subnet that already exists. All right, so let's test this. Oh, and let's just double check. Do show IP access list. And we can see anything from VLAN 8 to VLAN 146. And we are going to ping source VLAN 8. And that's not going to work because it is gig 1.8. Okay, a couple of missed pings there. That's okay. We should be able to come back here. IP NAT translations. And we can see that we got the ping traffic using the inside global, which is from our NAT pool, from the local, which is its actual address, to the outside local, which is the router 1's VLAN 146 interface. Cool. That's easy enough. Got a couple of notes there. So let's take the show output, because it's good to identify what is the inside, because this always trips me up. What is inside? You know what, we should grab this as well. Oh, and the reason I wanted to make that access list specific is that if, let's see, show IP route. Okay, so if our destination was actually beyond this, so let's do 7. I think it's 7.7. Check that, yep, 7.7. We should be able to ping that. We can see that it is going through that way. But if we do a show IP NAT translations, oh, we do. Why do we see that? Why do we see that NAT? It shouldn't match that. Interesting. I wonder if the destination side doesn't matter. Oh, I don't think it actually natted it. Oh, it did it because of the, okay. So it didn't actually, it did not, did it actually nat it? Interesting, that's something else to check. Is the destination in the access list actually used? I would have thought it would only hit anything going to there. But we can see right here, it's doing a NAT translation for it. Keep losing texture angular. I'm pinging beyond. All right, inside, let's go back to what we originally did. Inside global is the address, the traffic on the router. My local is actual source of the traffic from inside, side local destination address side global, in case I think we were doing it outside NAT, maybe. We'll still keep that as destination address. All right, so that's all written up. I think we're good here. Basic NAT. You know, while I'm looking at this, let me turn off notifications, turn on night shift, make it easier on the eyes. There we go. All right, so that was just a basic NAT. So let's move to the next one. Let's see. We need to, so this is going to be NAT overload. So let's make note here. This is basic NAT. And let's do NAT overload. Overload is next. And we are going to configure R8 to translate packets sourced from the loopbacks of R1, 2, and 3 using the address 108.8. Configure R8. Let's go to R8. Translate packets sourced from there using that. So I'm assuming that it needs to be going to their traffic is destined to R10, since we have to translate it to that. All right, because that's this address, this right here. So I think we're doing, okay. So let's do, so let's see, we got R1, R2, and R3. Okay. We are going to go to int.gig 58 IP-NAT inside int 108 IP-NAT outside NAT inside from source we're going to use a route map because there's nothing used this time. Call it route map NAT. We're going to overload interface gig 1.108. Overload it. I think what overload does is that it uses ports as its way of using a singular interface, if I remember correctly. So let's make our route map real quick before I forget. That's already a permit. We need a match IP address prefix, and let's copy and paste it. Don't need anything else because everything else should just be sent. Let's see what debugs we got. No, not doing any of that. All right, so let's go to R1. All right, so we're going to ping router 10 from loopback 0. Let's see, show IP NAT translations. None. So we did I did something wrong. Did something wrong. What did I do wrong? Called it RMNet, got that, copy and pasted that. Wonder if it doesn't like the prefix list. All right, so how would we do this access list if we only needed to permit routers 1, 2, and 3? All right, so I always try and do my naming with uppercases because then I know it's something I did. And let's do some subnetting math. All right. Wish I had a good way of doing this on the computer. Maybe I do. So I always use the cheater, 128, 4, 32, 16, 8, 4, 2, and 1. We need to be equal 1, 2, and 3. All right, so 1, 0, 1, 0, 1. And the rest of these are all zeros, as we know. Okay. Most common bit for all of them is actually this one right here. So we need to borrow 1, 2, 3, 255. Actually, we're doing a wildcard, so 3 bits. So it would be 150.1.0, 0. Probably helps if we do the permit IP first. Let's see, that's a host bit, or not a host, but we need that, And then we care about the first 3 bits and then don't care. And going to any. All right, let's cancel this out. And let's do IPNet inside source list. We're going to copy and paste that because typing is hard. Okay. Let's get out of that. Let's send our ping again. Let's go back to R8, show IPNet translations, and there we go. And we should be able to do the same. And you know what? We could copy and paste this too, because we're going to have to do it on R2 and R3. successful pings, and good NAT translations. Let's test the same from 4. Hopefully we do not see 4 getting translated. We do not, which is good. And we can see that it's just using different ports, and it looks like it's just counting up by 1 on each. So that's how we can track the state back and forth on that. So it looks like the route map doesn't look like I could use the prefix list and match it in there. And I'm wondering if that's show IP route 150.1.1.1. It has a /32. All right, so why didn't a prefix list matched in a route map work for the NAT source traffic? And this one we were pretty good with. So show run pipe section NAT, show run pipe section access list. So we got that. And let's get rid of that leading space in that notes because I'm particular in formatting like that. All right. So that's how NAT overloaded worked. It's also known as PAT. Port address translation. And we'll just use it, right, because it uses a different port number. So let's get the translation set in here too. Because you got to be able to verify, always be verifying. All right, let's see. Just check through the solution just to see what I did there. Yep, looks good. All right, next section is natting with route maps. All right, so we are going to R2 this time. We need to configure R2 with a route map-based NAT to support multiple outside interfaces. So we need to configure an additional sub-interface on R2. Okay. Encapsulation.1q2, IP address 155.1.2.2 /24. Let's see, what are we using? All right, so that should already be advertised through EIGRP because that's network statement's pretty broad. Show IP protocol just to be sure. 100. Yep. All right. Traffic from the loopback going to the point-to-point of 3 should be translated. And then traffic from loopback router to loopback out the point-to-point. Okay. All right. So we need to make an access list for R2 loop NAT permit IP 150.1.2.0, even though we know it's /32, we'll do it that way. And then we'll call this VLAN 2 NAT. And we just need to change this to be 155. Okay, so we have our two access lists that we need for the R2 loopback and R2 VLAN 2. Okay. We now need to make a route map. Going, so anything from route to loopback. Is there a way to do this in one NAT statement? Well, first I know I need to do this. IP NAT. Need to set our insides, and then going out to point to point. All right, I think this is what I'm going to do. We're going to match that. We're going to make a NAT pool, IP NAT pool. Pretty sure it's name. Then we got to give it an address. 155.1.23.200 is what they want me to use. And we'll just give it a prefix length of 24, because why not? And then need another route map. All right. Two different NATs, one needs pool, one's using the interface. Have the route map matching that. All right, let's see if this works. Let's copy and paste this out. Add it to our notes, nat with route map. So we need to ping. Let's check our routing. Let's see how everything is routing. Okay, so it's all going that way anyways. So ping the 1 source loopback 0. Okay, that got there. And then let's source it from VLAN 2. Okay. So we have it from our VLAN 2. It is getting natted to the interface, and we have it from, that looks like that worked. Let's just test it a little bit further. Let's go to router 10 for fun. Now let's source it from the loopback. We should have 2 new NAT translations. And we do. Let's see. All right. Yep. To router 10 to the NAT address. Perfect. Got a different port, and we're using the interface. All right. Let's check my work against the solution guide. So we made, yep, we made the right interface. Added the outsides correctly. All right, so I could have used a standard access list, but that's okay. Let's see. All right, so what they did in the solution guide is that they matched the point-to-point. All right, NAT out point-to-point from gig 2, deny. Okay. So I think my way works too. I did it with, okay, so they just specifically denied that the loopback can never get translated to the gig 20, the VLAN 23, and vice versa, that VLAN 2 can never get translated to that NAT. IPNAT, so out NAT PDP, deny this. So from the loopback, match that interface. So they put a match interface in there. I don't know if that's needed. Now they tested with telnet. So oh, did I misinterpret this? Configure to use. It just says going out. All right, traffic from R2's loopback going out the interface should be translated. But the way that they're explaining it in the answer is that everything is going to the interface of VLAN 20, or the outside interface of router 3. So I think the way that they wrote it versus the way that they made their solution don't actually match, but with what I got configured is legit. So I think that's good, so let's just add that to the notes. And let's see if there's anything else to know about route maps. I think it's just with the route map I can get a little more specific on my matches, so it can be like a multi-match thing. Cool. All right. Before I get to the next one for static net, I'm going to take a minute to go get some more water. So I will be right back. All right, back. Need some water. All right, we're gonna do static net next. And what it is asking is on R5, configure R5 so that R4 can reach R8's loopback using a new made-up address. Do not use a static route to accomplish this. So we already have some stuff configured on here. I know it says to basically restart the routers every time. I am not, or clear the configs each time. I do not do that because that wastes valuable time. I am using the INE racks. Let's clear all the nats. Now we should be able to delete those. So I am using INE's racks right now for all of this just because I don't want to deal with the headache of setting up my stuff. Setting up any of my stuff right now. I do have a home server that runs viral. It works fine. I just didn't feel like using it tonight. So let's see. All right. So we got the NAT translate. So we got to do a static NAT. So we'll leave the inside and outside because that is already good. So let's do IP NAT inside source static. And let's see the inside. So 155. So let's see the inside local is going to be that inside global. Let's see, I'm probably going to get this backwards, but let's test it and see what happens. Oh, I did something wrong there. I know I did. That doesn't seem right. That doesn't seem right. Because I need to get, because that would just be R4 to R4. All right. The inside local. So let's look at our past stuff. So the inside local was, and this, let's see, this was R8 pinging. So the inside local would be R8, and that would be the inside interface in this case. So let's do 155.1 dot, what is it, 1 going to VLAN 58, so 58.8. Inside global is 155.1.45.8, because the inside global on this was the actual NAT address. And let's see. So let's ping. We ping that, do show IP NAT translations. And let's see. So we have a ping inside global and the outside side. So that is router 4's outside going to there. Let's do a debug IP packet here, just for fun. Let's ping again. We should see a whole bunch of stuff on all. Oh, that's just, you know, do debug IP packet here, and let's send that traffic again. All right, we'll turn that off. Let's see, we have a whole bunch. Let's look through here. Let's see, what do we see? All right, well, let's check this solution. Let's see if I got this right. We have that working. Let's do some TCP traffic. Boy, this is going to be tough if I can't even spell telnet. Okay. Oh, I'm thinking of this wrong. I am thinking of this wrong. All right, so the NAT that we made, show section NAT. All right, we want to be able to reach R8's loop back or R8's interface, but having it look like it, but when we ping it doing this address. Okay, so this telnet's going to fail. We are going to ping this address. That address works. So now if we do a show IP NAT translations, we should see what we actually want, right? So let's just do 155.145.8. And there we go. Now we can telnet to it. All right. I understood this backwards. Yeah, because now we can see all right, let's just clear everything. All right, so we got this, the NAT configured here. R4 should be able to reach using that address that doesn't actually exist in a rep. If we look at the NAT translations, we can see the telnet traffic come in. So really 45 is the outside. Yeah. Okay. All right, I read this wrong, and this is something I need to work on. Configure R5 so that R4 can reach the VLAN 58 using the address 155.1.45.8. And what we did here on R5 is we created a static NAT that anything going to this destination, 155 or 155.1.58.8, can be reached by using this 155.1.45.8. So if I go one step beyond, let's go to R6, I should be able to go 155.1.45.8, and I can, but I should not be able to reach that anymore. Oops. And let's come here, show IP NAT translations, and we can see here it is. Two different. And you can't get to it on that because it's expecting to be natted at this point, right? I think that's what that is. Yeah, it's because, so I think this is the order of operations thing that I should probably look into is as traffic comes into an interface, it's gonna get natted before it gets routed. So it's looking at the NAT statement going, there is something saying go to 155. There is a NAT before that, if I remember correctly. And let's see. Verify traffic. Let's take the quick notes on this. We should just be able to do this. That's everything I think I need for the notes there. All right, so we got a bunch of things to look into on this. That is definitely one of my very, very weak points. And it's not something that I do every day anymore. All right, now we're going to do static pat. So we're going to overload. And let's just start the next set of notes. All right, so I got a bunch of things that I'm going to have to just read a little bit more. And we should probably save these notes just in case. Yes, I know it's in a notepad. I actually take all my notes in OneNote, but for this, for ease of use and everything, I'm going to use Text Wrangler. I like it even though it's not supported anymore, but that's what I like to use. All right. So we're doing some more natting on R5. And we need to do static paths. So let's first, so we're on pipe section nat, configure T. Let's get rid of this static nat. Cool. All right. Configure R5 so that when R4 telnets to 155.1.45.44 on a certain port, they get connected to R8's VLAN 8. And then do the same except to R10. All right, so we're gonna make 2 different static nats, and it's gonna be on a different port. So we know IP nat, inside, source, static. All right. So we know we want to go to 155.1.8.8. 23. But the inside global will be 155.1.45.44 on 80.23. And we know to do another TCP, and we are going to say when you go to our 10's VLAN 10, same address but different port. Oops, we forgot the port number there. And we know we want it to be telnet, which is 23. Okay. Let's test this one out. So we need to telnet to 155.1.45.44 on port 8023. And it is open. We get to R10, or sorry, R8. And then let's change the port number. Same thing, different port number, and we get to R10. Perfect. That is the results we wanted there. Let's check the NAT translations on R5 just to get everything. All right, this is making sense to me now. This is all making sense. All making sense. That's perfect. I think that was easy. That was easier to understand after doing just normal static NAT. So what we did here is that we're saying if you're going to this destination, which is R8's VLAN 8 interface on port 23, you can reach it from the outside by using this address, the 45.44 on port 8023. So this is what you would use to reach it on the outside. And this is what it would get translated to on the inside. And then we can use the same address on the outside, but we're using a different port, and that brings us to a completely different router, router 10's VLAN 10. The extendable, what is extendable? Extend this translation when used. I don't know what that means, which means I need to look it up and figure out what does this mean. This will be a research further. What does extendable mean? And that was added automatically at the end of this. You know what, we're just gonna copy this out, throw that right here, just so we know. just so we know where we found that from. But it added it automatically. I did not type that in. All right. I think that is good to go there. Let's check the actual solution guide. Yeah, I did it exactly how they did it. Tested it right. Oh, they have another command here. Show IP alias. Look at that. That's cool. That's a nice little handy one that we should probably remember. And you know what? Some of these notes are not going to start making sense unless I start highlighting. So let's, oh, you can't see that. Let's bring this over. Shrink it down a bit so it fits over on the top there. And we'll just do a copy of everything. A couple enters here. Let's give this a title, configuration, configuration or verification. I like capitals. All right. That's a question. That's another question. So let's make that red. Highlight that. Bold. Bold. Cool. And yep, this is where I want to be taking my notes. I've got quite the organizational thing set up here. It's a little much, but I think it makes sense to go a little deep like this. I'll probably actually what I should do is break these up into their own thing, but I will not bore anybody with that right now because that is not a good use of anybody's time right now. All right, let's move to the next lab. All right. Configure R5 so it does not add a local alias for the static mapping of this 45.44. I'm assuming that means I need to put this on here. So let's just go back to this, add that in here. Let's clear that out. Let's test our connections again. Both of them opened, worked perfectly. Show IP NAT translations. Good, got those there. Both of them opened. Both of them created translation. Now we got to do a show IP alias. And we do not see it here anymore. All right, so I don't know why we'd actually use that. The no IP alias feature will prevent a router running NAT from installing a local alias entry. However, the router will still respond to ARP requests for that global translated. It just won't terminate any connections itself. We can still verify. I don't know if that actually explains to me what the alias entry is for, though. This will probably be one of those things that will probably be one of those like a wording things. That will be like in a specific task of make it so that the inside global address is not able to terminate a connection or something. I don't know. That's an interesting one. I don't actually know what the point. So it still responds. So I'm wondering if it's just if something tries to go to that itself, because there's a whole bunch of other ports that are still open for it. So I wonder if that means if we just went without a port, what does that actually try and go to? Okay, those are both gone. Let's add these back in. Okay. Now it's still not telnetting to it. I probably should have enabled timeouts. While that's chiming out, let's see if there's anything else in here that I don't know what it is. We know what a route map is. Oh, no translation of embedded addresses inside. All right, that just must be a security thing. Mapping ID, that might just be so that we can more easily track it, and VRF is probably make VRF aware. Okay, so that's what happens if we do that. And I know I probably won't be able to do any of that stuff in the lab, but this is practice, so let's test that. Okay. Stops the router from actually responding to ping. All right, and that feature stops the router from responding from a direct ping. That's what it looks like it did. I'm sure if we tried to do any other protocol or something like that, it would probably get stopped as well. So I think that's what it does. All right, static policy NAT. You know what, we're going to start a new page for that, because that's how I like to organize things. All right, we're going back to R3. I don't think we did anything with that on here. We did not. Configure a static translation in R3 so that when traffic is received from R7 and it's going to the point-to-point R1, it gets translated to 13.7, and configure a static net so that when traffic from R7 going out the point-to-point R2 is translated to 23.7. Okay. All right. All right, so either way, we need to figure out what our inside and outside is. And we are going to two different routers, right? So everything's coming from R7. So that would be our inside interface, 37 IPNet. And then we're going to be translating out our R1 interface, IP outside. Man, my typing is bad. And then we also need to translate to R2, IPNet outside. Okay. Configure a translation on R3 so that when traffic from R7 and is going to the point-to-point of R1, it is translated to that. All right, so we need to match interfaces somehow. And the only way to match an interface is with a route map. Route map. R1 interface match int gig 1.13. And then we're going to do a for R2 int match int gig 1.23. Okay. IPNet inside source static. It doesn't say we're doing any port address, so we can just do everything. So anything that's coming from the there, we want to translate it to 155.1.13.7, and we're going to match it from the route map R1 int. Okay, we're going to do, you know what, I'm going to type the whole thing. I'm not going to shortcut it because I need to practice. 155.1.707 to 155.1.23.7. That's what we want to translate it to, and if it matches the R2 interface. Okay, so we got our two nats to do show route map. All right, how do we test this? So let's test it with telnets. All right, I did something wrong. Oh, I know what I did wrong. Probably helps if I source the traffic, doesn't it? Got to remember to source the traffic. ping, you know what? Telnet 155.1.1.1 source /source, because why would anything be the same everywhere? No, maybe it's 13.7. No. Oh, I'm not going to the right address still. Still not going to the right address. Because I'm a dummy, because I need to be going to this interface, because I said match the interface in the route map. Right? Do show IP and right, because I said match these interfaces. Okay, so from R7, it's not dot that, it is. There we go, now that's open. And let's test R2. That should open. Perfect. All right, now we come back here. Do show IPNet translations. And now we see it both works. Let's do that one more time. Show users. And we can see that it looks like it's coming from there. That's how we verify that. And then if we exit out of this, go back to R1, do show users. I should be able to run that. And it looks like it's coming from 13.7. Okay. That makes sense. So what we did, so let's go back and re-talk through this. All right, so what we configured is anything that is coming from this source and it's going to get translated to this, but only if it matches going to that destination in this, or only if it matches what is in this route map, which is anything going to R1's interface there. All right, so this is our inside. Yeah, because that's our inside local. That's what it's going to get translated to. So that would be our inside global. And we are only doing that if it matches that route map. And let's see, what does this say here? Allows map, so static NAT, static policy NAT, so a static NAT with route maps. So that's okay. That makes sense. Let's copy this out. Put this in here. Let's get this. Show output, and then let's go back to R7 and you know what, let's just do R2 one more time so we can do a show users. And then that way we can see how did we actually verify it. Now let's highlight. So let's add some space. And what we are looking for here is this right here. And that specifically because we are doing from this guy you're going to get translated to this if it matches what's in this route map. Now let's just give some space here for readability. All right, that makes sense. I think the wording is going to be the part that's going to trip me up a bit. That's okay. All right, TCP load distribution with NAT. All right, disable VLAN 45 on R5. Shut that down. Configure a rotary NAT R5 so that when R8 telnets to an address, it is redirected to R1, 2, and 3 in an even distribution. All right, let's see what that does. All right, so we can still get to those over the tunnel. All right. I don't even know if this is static or not. No, I don't know where to look for that. That's because it's not going to be a static NAT. Oh, man. All right, well, this now becomes outside. Need to enable that on the tunnel. All right, so I needed to check the solution guide for this one. Normally I would probably I shouldn't have just skipped to that. I probably should have checked through the doc CD first to see if I could find the config guide on that. So let's do that. Let's bring this over here. Should be able to see that now. Now we can see how terrible I am at finding things in here. If anybody knows any tricks on how to find stuff in here faster, I am all ears for that. It's not under network management. It wouldn't be under system management. I think it's an application. No, thought it would be under IP. That's what I just clicked on, isn't it? Sure is. IP switching, IPv6. That's not what I want. It's not first hop. Oops. All right, well now I think I'm wasting everybody's time. But you know what? This is for me. Is it under WAN? Nope, old stuff. IP Pro. Yeah, there it is. IP independent. Right? I thought I just saw it. Oh, it's under IP addressing? Look at that. I should have checked there. There it is. It helps if I spell rotary right. Oh no, I think I did. Yep, I did. Cool. I don't even think this is in the config guide. There it is. Oh, TCP load. There it is. All right. So we should definitely save this page and get back to it. And this will be some reading for me. Let's see if there's a configuration example for that. But this will be a good one for me to reread again. I think I am overdue for that. Yeah, all right. Well, let's minimize that for now. Let's take a look at the solution guide and let's just step through it. All right, so what we need to do first is we need to configure our rotary pool. So IPNAT pool rotary. I'm going to get a prefix length of 24. Its type is rotary. Okay, and in there, let's see, what do we need to do? We need to set up an address. We need it to be the destinations on the other ends of the tunnel. So we are doing R1, R2, and R3. Let's get out of there. We then need to make an access list. for load balancing. So permit, so source is anything. Configure a rotary NAT5 so that when RA telnets to 150 or to 58.5, it gets translated to any of those. So our load balance, okay, so it's the destination. So from anything going to 58.55 equal to telnet. And we're going to do a destination one this time with the list load balance from the pool rotary. Oh. And it also says I need to make an alias. Well, let's see what happens without doing the alias first. So, from here, we just need to telnet to 155.1.58.55. Doesn't do anything. And I think that is because we do not have the alias. Let's see. So let's wait for that to time out. All right, RA should have timed out. Do show IP NAT translations. We got nothing except for the old stuff. Let's put in that. Now we put in the alias. Show IP alias. That should be a static alias on that port. Now let's do this. Nothing. Still nothing. Let's get rid of these, because these might be screwing up with it. Oh, you know, let's put those back, because I don't think those are screwing up with it. I think it has to do with that I have, nope, I thought I had that, okay. I've got the inside on there. That just didn't work. 155, 150. All right, let's get rid of these. All right, so something got messed up somewhere. we got this. Oh my God. Okay. We have matches. Permit TCP anything to the host equal to telnet. 58.8. We have the IPNAT inside destination list to load balance. LB, pool, rotary. Rotary pool has a prefix length of 24. And it can get translated to either of those. Nothing. I wonder if that's screwing this up. Why aren't you working? Well, what we're trying to do is a very poor man's version of load balancing, something like a load balancing device like an F5 or something would do. Let's get rid of that. We shut down VLAN 45. We have IPNet outside there. We have IPNet inside there. We have the pool and this. LB, rotary is spelled right. Rotary. We have the alias there. 58, 155, 58 dot. I don't know what else to check. think I have it configured correctly. I just don't know why it's not working. Should be working. Because the way that it's connected is R8's connected to R5 over interface 58. I can ping that. I can ping that. But we can't telnet. Can we telnet to that? Sure can. I don't know. I don't know. I have to table this one. Not sure. Not sure what's going on with that. Not sure. But what should be happening is that anytime that I telnet from R8 to the 58.55 address, it should in sequence or round robin between hitting these different devices. As to why it's not, I don't know. There's no old NATs. I'm wondering if it's because I've been changing a whole bunch of stuff on R5. Maybe a reload would fix it. I've been doing a whole bunch of stuff on it. Let's try. Let's try. While that's doing that, we're going to go to the next one, which is NAT default interface. Let's see, there's motion outside. Nope, just neighbors coming home. All right. All right, NAT default interface. All right, it wants me to use R5 again for this. And to disable the DMVPN. So kind of can't move on until this gets all the way back up. But what we're going to need to do is disable the DMVPN network, then configure R5 so that all connections destined to the point-to-point link to R4 are directed to R8's loopback interface. All other inside to outside traffic should be dynamically overloaded. I don't understand the wording of this one. I thought these came up faster. All right. Looks like routing's coming up. Should be good. New adjacency. Nothing. Nothing. After all that. After all that, nothing. I will put that out there. That probably ask some friends as to what is going on and why that didn't work. I am running out of time for labbing tonight. Rack time is going to end in a few minutes. So let's rehash what did we get through. So we did basic NAT, which is we need to be able to identify the inside and outside interfaces. So we got to do IPNet inside or IPNet outside. We then identify the source of the traffic and then build the NAT pool, right? So source to destination in an access list. We then built a pool for where we were going to translate our addresses to. And then we built the actual NAT, basing it off of the access list and using the pool to translate. And then anytime we sent any traffic, it would get translated. Defined inside global, which is address being used to NAT the traffic on the local router. And the inside local is the actual source of the traffic. And then the outsides are the outside addresses. Let's see. I don't know why the access list wasn't matched exactly, but I'm thinking that as I read more through the actual configuration guide, that should get talked about in there. So I'll read that. That'll be some late reading later. Pat, that one was pretty easy. We just had to match. Let's see, what was this one? Oh, we tried to use a prefix list, needed to use an access list. I think because the route map is applied differently. Yeah, it is applied differently because we are matching different clauses, but we're also still coming back to matching an access list in there. So let's see. So we only wanted R1 through 3, so we had to do some subnetting. We found that the most common bit, it was 3 most common bits, and because it's a wildcard, that actually worked out in our favor because we didn't have to do any math. Yeah, that I think that would have been a 252. And then we built the NAT, so that went R1 to R3. So we matched anything that was coming from R1 or R3 loop back, that it would get padded over gig 108, and the overload was what allows for the port address. NAT with a route map. All right, so what we did was we made a pool. We had to translate it to that specific address. We then matched a route map, which then matched an access list. We probably could have made it more specific in matching the access list and its destination address, but the wording of the question didn't say that specifically. So that should be okay there. And then we did a static NAT. With the static NAT, we just did a one-to-one translation. So anything, so whenever, so when we wanted to reach router 8 on this, we wanted to reach router 8, but from the outside, we would actually hit 45.8, and that would get translated to R8's address there. So that's what we were doing. And I verify the order of operations. I'm like 99% sure that it was natting before route, nat before your route. And I think it's nat, then policy route, then route if it's in if it's traffic coming into the interface. Gotta look that back up. I should probably post that on my wall so I can see it every day. And we did a static pat, which is basically the same thing except with port numbers in it, so we could use one address on the outside, use different port numbers, but get to different devices on the back end. Got to over research what the extendable means a little bit more, and also that it's interesting that it creates a dynamic alias. And then what the no alias means is that the router stops actually responding to that. We then did static policy NAT with a route map, or it's a static NAT with a route map. We were saying anytime you want anything from this from router 7 on this interface would get translated to 13.7 if it matched this route map, which is match anything going to this interface. And that's what we see here. We verified it by doing a telnet and doing a show users, and we can see that we did get translated to that right address. And then the TCP load balancing with NAT distribution, this is a rotary pool and a IP NAT inside destination, blah, blah, blah. And we had to match an access list a traffic we want translated. All right, and then let's just steal the config that we did. And that should be up here somewhere, definitely on R5, and we can see that we got kicked out of everything already. I'm pretty sure I did a show run. Yep, I did. Yeah, let's copy this too. Put this in here. We'll bold that just because. All right. Well, I think this is a good step back into the whole labbing for the night. Hopefully the live stream worked well. I tested it a little bit at lunch today just to see if I got all the sound and everything. It looked like it was working right. So this almost 2 hours in. I think I'll call it a night and get back to it tomorrow. So let's see. If there's anything else I was thinking of, I don't think so. I will try this again tomorrow. Probably continue with some IP services stuff. That's still a little tough for me to remember everything. And I also just want to get back into the groove of actually labbing every day, just because I've been really bad at it lately. So thanks for anyone that's watching into the future, since I didn't post this publicly when I live streamed it. Wanted to just test it out and see how it worked, but I think I'll make this video public in the next couple days or so. But this was definitely interesting, and for recording myself while doing the labs and then talking it out loud, it actually helped me focus a lot better. So I think I will continue to do this and see if it helps. All right, everyone. I'll see you next time.